Welcome to School Page Video Teacher. Tenth CBSE Physics Chapter Reflection and Refraction of Light. After watching this video, you will be able to understand the phenomena of refraction of light, refraction of light through a rectangular glass slab, and the laws of refraction of light. Take a look at this pencil immersed in water. You may examine that the pencil appears bent. So what do you think? Is the pencil really bent? Let us look at some of the other examples. You might have observed that the bottom of a tank or a pond containing water appears to be raised. When a thick glass slab is placed over written text, the letters appear raised when viewed through the glass slab. So what is the reason for all these cases? Why does the pencil appear bent? Why does the bottom of the tank appears to be raised? And why does the letters appear raised? All this is possible only because of the result of the phenomena called refraction of light. In our previous videos, we have studied about the phenomena of reflection of light. According to the reflection of light, light rays bounces back after hitting an opaque surface. So this is an opaque surface. This is an incident ray. It gets reflected in this direction. When we draw a normal here, angle of incidence will be equal to angle of reflection. Whereas in case of refraction, the light does not bounce back the surface, it starts going through a different medium. Let us consider two different mediums, air and water. So this is air and this is water. Let us draw normal. Let us consider a ray coming with some angle θ1. This incident ray, instead of going in this direction, it will bend a little bit and go down in this direction. So this is the refracted ray, θ2. We know that the light travels in a straight line path. This is true as long as the light rays are traveling in the same medium. If the light rays are made to go from one medium to another, the light rays change their direction or bend at the boundaries between the two medium. This change in direction of light when it passes from one medium to another is called as refraction of light. Let us go back to the same example when a pencil is immersed in water. As the pencil passes from air to water, the light bends at the separation of two media. That is, the velocity changes and hence it deviates from its path. This property of light is known as refraction of light. Two terms are very important to understand refraction of light. Optically rarer medium and optically denser medium. It can also be called as a rarer medium and a denser medium. Rarer medium has low density, whereas a denser medium has high density. So here in case of air and water, water has high density than the air. So air is rarer and water is denser. So when a ray of light moves from a rarer medium to a denser medium, it bends towards its normal. So this is in case of rarer to denser. Let us see another case when a ray of light moves from denser medium to rarer medium. So if this is a normal, this is water which is denser medium and this is air which is rarer medium. This is an incident ray of light which is moving at an angle θ1. So in this case, the refracted ray of light moves away from the normal. So let this be some angle θ2. So this is one of the most important difference to be known to study refraction. So ray of light going from a rarer medium to a denser medium, it bends towards its normal. Whereas when a ray of light is moving from denser medium to its rarer medium, it moves away from its normal. Now let us understand refraction through a rectangular glass slab. Consider a rectangular glass slab. So this is a rectangular glass slab. Let us consider a ray of light passing through the glass slab. So this will be the rarer medium and this will be the denser medium. So when a ray of light passes from a rarer medium to a denser medium, this is an incident ray which is passing from rarer medium to denser medium. Let us draw normal. We know that the refracted ray of light bends towards the normal. So this is the refracted ray which bends towards the normal. So this is angle of incidence and this is angle of refraction. And when the ray of light enters from glass to air, that is from denser medium to a rarer medium, so this is a ray of light, this is the normal. So light bends away from the normal. So this is angle of refraction and this is angle of emergent. This ray is called as incident ray. This ray is called as refracted ray. And this ray is called as emergent ray. If we extend the incident ray, we may notice that the emergent ray is parallel to the direction of incident ray. This is due to the phenomena of refraction of light. So refraction is due to change in the speed of light as it enters from one transparent medium to another. The perpendicular distance between the original path of incident ray and the emergent ray is called as lateral displacement. The refraction of light on going from one medium to another takes place according to two laws, which are known as laws of refraction of light. According to the first law, the incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. So this is the first law. The incident ray, the refracted ray, and the normal to the interface of two transparent media at the point of incidence all lie in the same plane. This law is true because the incident ray, the refracted ray, and the normal all are in the same plane. It is not that the incident ray is in this slide and the refracted ray is in some other slide. All the three meet at a same point of incidence. This is called as first law. According to the second law, the ratio of sine of angle of incidence to the sine of angle of refraction is equal to a constant. So this is the second law. The ratio of sine of angle of incidence to the sine of angle of refraction is a constant for the light of a given color and for the given pair of media. This law is known as Snell's law of refraction. So the relationship between the angle of incidence and the angle of refraction was experimentally discovered by Snell in the year 1621. Hence this is called as Snell's law. It can also be written as Sin I divided by sin R is equal to a constant. This constant is called as refractive index. Suppose a ray of light traveling in air enters into another media, that is water, and gets refracted. The value of constant sin I divided by sin R for a ray of light passing from air into a particular medium is called as refractive index of that medium. Refractive index is usually denoted by the letter small n. Hence, Snell's law can be written as refractive index is equals to sin I divided by sin R. Let us try to calculate the refractive index of some substance X. Suppose the angle of incidence for a ray of light in air is equal to 47 degree and the angle of refraction be equal to 35 degree. Refractive index is equal to sin I divided by sin R. This is equal to sin angle of incidence is given as 47 degree and angle of refraction is given as 35 degree. We know that sin 47 degree is equal to 0.73 and sin 35 degree is equal to 0.57. On further simplification, we will obtain 1.28. So refractive index of substance X is equal to 1.28. Since the refractive index is a ratio of two similar quantities, it has no units. The refractive index of a medium gives an indication of the light bending ability of that medium. After watching this video, now you can understand the refraction of light through a rectangular glass slab, and the laws of refraction of light. Thank you for watching. For more videos, visit our website videoteacher.schoolpage.me.